Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explores residual analysis and its place in linear regression. Let's get started. So, first, in order to understand residual analysis, we have to understand what residuals are. Residuals are simply the difference between an observed value and the predicted value from the regression equation. And when I'm talking about values, I'm talking about the y portion of our ordered pairs. So the residual is simply the observed y value minus the predicted y value. So if the prediction line is underneath the observed line, then the residual will be positive. If the observed point is below the residual line, then it's going to be negative. We write that mathematically as y minus y hat. Y is from the observed data, where the data points actually lie on the plot, and y hat comes from the regressional equation. This is the prediction from the residual. From the data points, and it's that difference that makes the residual. So here we have some data for shoe print length versus height, and notice here that we have most of our data. Some of our data has been removed, and so we're only looking at selected points because we just want to illustrate the concept of residuals. So we're looking at these 6 data points that you see here on the screen. So here's our regression equation, and we can use that regression equation to make predictions for each of the x variables that we see in our table. So now we've got observed values for y, which come from the data points themselves. That's the second column in the table. And we've got predicted values for y using the regression equation. That's the last column in the table. So now if we subtract the predicted from the observed, so take the third and subtract from the second, we get another column which lists the residuals for this data set. So looking at this first data point here, 29.7, 175.3. That's this data point listed here towards the bottom of our scatter plot. And we have a residual of negative 2.1. So that means the distance from that data point to the regression line is 2.1. The negative sign just means that the data point is below the regression line. Let's take a look at this example. So this data point, 30.6, 181.6, it has a residual value of 2.7. And so that's simply the distance between that data point and the regression line. Notice the residual here is positive. That means the data point is above the regression line. And we could make the same calculation, demonstration for each of the data points that we have here on the screen. So the residual is simply that vertical distance from the data point to the regression line. If it's negative, it means the data point is below the regression line. If it's positive, it means the data point is above the regression line. We can actually make residual plots by replacing the y values from our ordered pairs we normally plot on the scatter plot with the residual values that we calculated earlier. And when we plot those data points, we get what's called a residual plot, because the points that you're plotting contain residuals for the y value. So here's a plot of our data. We've got all 10 data points for shoe print length versus height. And here's a plot for the residuals. This is the same data, but notice the residual plot looks rather different. It's because you're plotting different values for y. So take this first data point, for instance, 29.7, 175.3. So that data point is located here on our original scatter plot. The residual for that line is negative 2.1. So that means we replace the y, 175.3, with the residual, negative 2.1, and now we've got a new ordered pair to plot on a residual plot, and that same point ends up here. And we could look at another point, 29.7, 177.8. That point is listed here on the original data plot. We can actually make residual calculation with that. So replace the residual, and it comes out to be here on the residual plot. And we could say the same thing about the remaining data points. So for every one that we plot on the original plot, we can replace the y value with its corresponding residual and get a different organization of the data points on the plot. What value does this have? Well, residual plot analysis provides another tool for evaluating regression models. So you're going to be looking for patterns in the way that the points are represented on your scatter plot. Consider these criteria when you're looking for trends. First, the residual plot should not be showing us any obvious patterns, not even a straight line pattern. So what we want to see is scatter amongst the data points. We want that shotgun effect, because in a residual plot, when you have that spread of the data points, it confirms that the scatter plot of the sample data is a straight line pattern. So if we have a pattern to the residual plot, then that means the original scatter plot for just the data points themselves is not going to be showing a straight line pattern. The band of data points in the residual plot should not become wider or narrower when viewed from left to right. Your author uses the terms thicker and thinner, which really isn't appropriate because you're looking at a two-dimensional surface. Thicker and thinner actually describe three-dimensional objects, so yeah, not really the best of language. But that's okay. We kind of understand what's going on here. The reason for this requirement is that it confirms that for fixed values of x, the distributions all have the same standard deviation. And that's important because that's typically a requirement that we have for some of our methodologies. So if we use these criteria to evaluate the residual plot, then look, we don't have any patterns here, and it doesn't look like anything's becoming thicker or thinner, as your author would say. So it looks like we're good. Let's look at some examples to illustrate what's not good, what we don't want to see. So first of all, we don't want to see any obvious patterns to the data set. So here we've got an obvious pattern, sinusoidal. So the data points go below the zero line, then they come up, then they go back down again. Okay, so there's an example that we don't want to see in our data set. It's a distinct pattern. It suggests that our data has no linear correlation. Of course, we want linear correlation. So when we see this pattern in our residual plot, it makes us really sad. Not depressed, but just sad. Another thing we don't want to see is where you've got like a band of data that gets wider or narrower as you go from left to right, like you see here. So notice how these data points are following a band, and the band is actually getting wider as you go from left to right. This suggests that unequal standard deviations are at play in our model. And we don't want that because that doesn't make for a good model. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at aspireboundacademy.com. Thanks for watching. I'll see you in the next video.